In this video, I'm going to be modeling for you and talking you through some of the concepts that we work with in area and perimeter in 4th grade. So first of all, I want you to know that we still are focusing on rectangles. They will eventually get to triangles and circles, but in 4th grade, we're still focusing on rectangles. They learned this skill in 3rd grade, so we're just adding on to it and looking at other experiences and moments when you might be needing to find area and perimeter. So number 1, rectangles. Number 2, yes, they might sometimes be asked to find the area and perimeter, but sometimes they have to make an inference. If a question is asking about fencing or picture framing or trim around a door or a floor, they need to infer that they need to find the perimeter. But if a question is asking about tiling on a floor or carpet or paint or a tablecloth, they need to think of area. So they need to be able to infer that. They're not always told with the word area and perimeter. They have to think about what's happening in the story. All right, so now that we know kind of what they might see, let's just all be on the same page about the difference between area and perimeter, because they are both a measurement of a rectangle, but they use some of the same numbers, but they're measuring different things. So area is the number of square units that a rectangle covers. And we'll talk about what that means by covering and the square units. But you'll often see the use of the formula length times width. And I'll explain to you why you use that formula here. Perimeter is the distance around a rectangle. So area is all this space covered inside. Perimeter is just the distance around. That's why we think fencing, picture frames, things like that. There are different ways a 4th grader might think about the perimeter. They might think about add up all the sides, and so they would put every side in the equation. Or they might notice, well, 2 sides are the same, the 2 lengths are the same, the 2 widths are the same, so let me do 2 times the length plus 2 times the width. Or they might add the length and the width together and then multiply that by 2. Whatever makes sense in their brain, but what you want to watch out for is they're not just going 5 plus 3. Because oftentimes they're only given 2 dimensions, so they need to know that they're not just adding 5 plus 3. And we'll get into that, what they need to do as their first step. So I'm going to show you how to find the area and perimeter, and then I'm going to talk to you about another aspect they might see. So here we have our area. We have 5 feet by 3 feet. Maybe that this is a garden, or maybe it's a basketball court. Whatever it is, we're trying to find out the space it's covering up. So the reason that we do length times width, and the reason we use multiplication, is because area, this covering, there's an invisible array inside of here. If I draw the array out using 5 columns because it's a 5 and 3 rows because it's a 3, I'm going to get the same product by multiplying 5 times 3 as I would by counting here. So 5 times 3, or 5 groups of 3, is 15. And if I counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 square units going 1 foot by 1 foot by 1 foot by 1 foot, 15 times inside of here. And think about it, 5 times 3 is 5 groups of 3. There are 5 groups of 3 in this space. So 15 square units, and I want to make sure that I label it as 15 square feet because there are squares going 1 foot around, 15 of them. All right, so that is area. Moving on to perimeter, I have the same rectangle, but I'm going to find a different dimension for it, or a different measurement for it. So here, remember, perimeter is the outside here. So maybe they want to put a fence around that garden or lines around that basketball court, and they need to know the length of them. So here I need to add the lengths and the widths. I could use any of these formulas, whichever way my brain works. My brain typically wants to add the lengths and then add the widths. But what I want to make sure is I'm not just doing 5 plus 3. So 4th graders need to remember, well, how do I know these other sides? Well, one of the attributes of a rectangle is opposite sides are equal. So this is also 5 feet, and this is also 3 feet. So my brain best works by going 5 plus 5 is 10, plus 3 is 13, plus 3 is 16. That's the one I just used there. Or they could do 2L, so 2 times 5 is 10. 2 times 3 is 6. 10 plus 6 is 16. Or they could do length times width. Length plus width is 8 times 2 is 16. So no matter which one I use, when I use all of the sides, it is 16 feet. Square feet, linear feet. Okay? All right, so that is just plain old find the area of this space. Sometimes fourth graders will be given an area or given a perimeter, and they have to think backwards about what that space might look like. So maybe you're given the area of 16 feet and you're said, well, what might that space look like if there's an area of 16 feet? What are some different options it might look like? Maybe it's that garden or that basketball court or that patch of grass that they're playing on, whatever it is. You kind of have to think backwards a little bit. Well, what I for sure know is that this 16 square inches was found using a length times a width. So I know it was length times width equals 16. So now I need to think, well, some fourth graders right away know that they are factors, that 1 times 16 is 16, 2 times 8 is 16, 4 times 4 is 16. So if you know that, if you're fluent with your factors and multiples, then you'll right away know that those are some of the options. If you are not fluent, then you might think back to one of the strategies we used at the beginning of the year where you make a T-chart, and you know right away every number has 1 in itself as factors, and then you would think 2, 4, 6, 8, 10, 12, 14, 16. Oh, I needed to count by 2 8 times. So 2 and 8. If I did 3, I would not get right at 16. If I did 4, 8, 12, 16. Oh, I needed to count by 4 times. So if I did all of my single digit numbers, I would get 1 and 16, 2 and 8, 4 and 4 are our options. So that space might look like this. That space might look like this, 2 and 8, or it might look like a square, 4 and 4. All three of these options give me 16 square inches. So I thought backwards to, well, how do you get that number? Oh, I use this length times width. Well, what are two numbers that multiply to get 16? So that's the thought process there. Let's think about perimeter backwards. You're given a perimeter of 20 inches, and you thought, well, what could that space look like? Well, that means 2 lengths and 2 widths were added together to make 20. So I got to think of numbers that work well to make 20. Well, you got to be careful there because, yeah, 19 and 1 make 20, but is that 4 sides? And also I know that, well, I could do 10 and 5 and 3 and 2 make 20, but is that 2 sets of equal sides? So you got to be careful. Perimeter is a little bit trickier. So sometimes what I like to do is I just like to think about numbers that work really well together. Or are easy to work with. Like 5 is easy for me to work with. So if I put 5 here, I automatically know 5 goes here. So that right there, 5 and 5, gave me 10. And then how much more do I have to work with to get to 20? Well, 10 plus 10 is 20. And then if I split that, it's back to 5 and 5. So that one actually ends up being a square. I can do 4 sides all being 5, but it's not always going to work that way. So let me think of a different option. Let's see if I did, let me do 7 and 7. If I did 7 and 7, so if I did 7 plus 7, that would give me 14, but I need 2 more sides. So to go from 14 to 20, that's 6 more, total more. So how do I split that? Oh, that's 3 and 3. So I could have a 7 by 3 rectangle also give me a perimeter of 20. So here I found 2 options just by kind of using a number that I know could work on one side and then using the remainder to split apart for the other sides. Okay? So these are 2 ideas 4th graders do need to be able to work with in area and perimeter, just basically finding the area and perimeter and then being given an area and perimeter and being able to think backwards to, well, what could that rectangle or that space look like, okay? So keep that in mind when you're doing area and perimeter, that these are the formulas that they need to be able to work with, and that area is the square units covering all inside that shape, whereas the perimeter is just the linear units around that shape.